Welcome to this YSL tutorial. In this video, we're going to explain how to use dictionaries in Excel VBA. And we'll start the video by quickly comparing dictionaries to another type of object called a collection, which you may have seen in previous videos in this series. Once you've made that quick comparison, we'll then explain how you can create a new dictionary object, first of all by setting a reference to the scripting runtime object library. Once we've created a dictionary, we can show you how to add items to it, and then also how you can count those items and remove them if you need to. We'll explain a couple of different techniques for referencing items in a dictionary, either by key or by index, and then go into a bit more detail about dictionary keys, showing you how you can test if keys exist, how to edit keys that exist in a dictionary, and also how you can change the compare mode for keys, so you can make your keys case sensitive or non-case sensitive. For the final part of the video, we'll look at how you can loop over the items in a dictionary, which works slightly differently to that for a collection, looping over a couple of different arrays that the dictionary contains. So there's quite a lot to do. Let's get started. In the previous two videos in this series, we've looked at how to use VBA's collection class to allow you to define your own custom collections of objects. So in this example, we've declared a variable which can hold a new instance of a collection, and it's designed to hold objects of a custom film class defined in this class module here. We've created a new instance of our collection, and then we've looped through a range of cells, creating a new instance of the film object for each cell we encounter, and then once we've set some basic properties of that object, we then add it to the collection using the collection's add method. Once we've finished looping, we should display a simple message box which uses the count property of the collection to display how many items are in the collection. So if I run the subroutine, we'll see that there are 13 films in the collection, so this is the list of films we've looped over, which isn't a particularly useful example, but just to demonstrate the basics of how collections work. Now, the collection class isn't actually VBA's only way of allowing you to build a custom collection of objects. There's also a class called a dictionary. And in this video, we're going to talk about how the dictionary class works and what subtle advantages it gives you over the bog standard collection class. For this simple example, you'll see that fundamentally it works in exactly the same way as a collection class, having just changed the two words collection to the words dictionary. If I run the subroutine again, I'll get exactly the same results. So it's very, very similar in terms of purpose and design as the collection class, but provides you with just a couple of subtle little advantages over what the bog standard collection class does. To begin using dictionaries, you'll need to declare a variable which can hold an instance of the dictionary class. So let's begin a new subroutine, which I'm going to call using dictionaries. And then I'm going to declare a variable, which I'm going to call my dictionary. And what I would like to do is set a reference or use a type called a dictionary. Sadly, that doesn't appear in the IntelliSense list by default. The dictionary class isn't actually defined in any of the standard Office applications. It's actually defined in another object library altogether called a Microsoft Scripting Runtime object library. You might remember this if you've watched our previous videos on using file system objects to manipulate files and folders, or creating text files and text streams. If you don't remember it, then I'll show you quickly how you can set a reference to the object library by heading to the Tools menu, choosing References, and then scrolling through the huge long list of references to find Microsoft Scripting Runtime, which I've sadly scrolled all the way past. Go back up a little bit, there it is, Microsoft Scripting Runtime. So make sure you check the box next to the Microsoft Scripting Runtime, and then click OK. And then at that point you will be able to reference the dictionary class when you declare variables. Next, we need to create a new instance of the dictionary class before we can begin adding items to it. So we can do that in a couple of different ways, but here's a fairly standard way of doing it. We can set my dictionary equal to a new instance of the dictionary class. And once we've done that, we can begin adding items to the dictionary object by using the add method. So I can do that by saying mydictionary.add. And if you watch the previous videos on using the collection class, you'll immediately spot how many extra methods and properties there are for a dictionary compared to a collection class. We'll investigate some of these later on in the video. For now I want to focus on adding items to it, or at least one item to my dictionary. So using the add method for a dictionary is subtly different to that for a collection. So with a collection, I have to specify the item first and then the key. With a dictionary, it's the key first and then the item. And with a dictionary, the key parameter is compulsory, whereas for a collection it's optional. So for a dictionary, I must specify a name or an identifier for the object that I'm adding to my dictionary. So what I'm going to do first of all, I'm going to add the worksheet 1 object into this dictionary. So I'm going to give it a unique name for the key, sheet 1, And then the item that I'm going to pass in, I'm going to set a reference to Worksheets, Sheet 1. Now, just as with a collection, there's no limit to the types of objects you can add to your dictionary. So if I wanted to add more items, let's say I wanted to add a workbook as well, I could say my dictionary.add, and I can create a key that's going to reference this workbook's name. So the name property of the workbook, and then the item I'm going to add is going to be this workbook. I could also add a chart or an instance of a custom class. So if I declared a variable which can hold an instance of my custom film class, I can say dimf as film, and then I can set f to be equal to a new film before adding it to the dictionary. So I can say set f equals new film, and then I can say my dictionary.add, and I'm going to use a unique key. I'm going to call this film1, and then the item I'm going to add is going to be a reference to my variable f. So just like with a collection, you can add multiple items to the dictionary explicitly like so, and there's no limit to the types of objects you can add to the dictionary. Another feature that works just like the collection class is the ability to count the items in your dictionary. So if I wanted to display a count of the number of items, I can display a message box, for example, and I could say there are, and then use an ampersand to concatenate the count property of the dictionary class, and concatenate items in the dictionary. I didn't really need this extra little bit, but I wanted it to make sense when the message appeared. So when I run that subroutine, I should be told that there are 3 items in the dictionary. So exactly like the way the collection class's count property works. The dictionary class also allows you to remove items once they've been added, but this works subtly differently to the way the collection class method for removing items does. So if, before I display my message box, I say my dictionary.remove, when I tap in a space, I'll see that I have to pass in the key of the item that I want to remove. So for example, I could remove film 1 or sheet 1, doesn't really matter what I remove. If I say sheet 1, and then if I run through the subroutine again, if I press the F5 key to run it, I'll be told there are 2 items in the dictionary. Now what I can't do if I want to remove an item with a dictionary is use an index number to reference the item. So for instance, if I for a dictionary the items collection is a 0-based index. So if I put in the number 1, that would remove the second item that I'd added to the dictionary. But if I run the subroutine at this point, then it doesn't work because you can't use an index number to reference an item in the remove method. I can actually do that with a collection class, however. If I go back to my using a collections module, and if I put in here, just before I show my message box here, I can say my films.remove, and I can actually pass in either an index number or a key. So if I pass in the number 1, so collections have a 1-based index of their items, if I do that, I can remove the item based on the index. And it tells me there are 12 films in the collection because one of them has been removed. So that works subtly differently to the way a collection does. When you remove items individually, you must reference them by their key, their alphanumeric value, rather than by their index number. Now, although removing single items from a dictionary is slightly more restrictive than for a collection, the dictionary class does provide one fairly convenient way to remove all of its items. So the dictionary class has a remove all method, which, as the name suggests, removes every single item from its list. So if I were to run through this subroutine now again at this point, I'll find out that there were 0 items in the dictionary because I've removed them all immediately before I display my message. And that's something that you can't do with a standard collection class. Just as with a collection, if I want to refer to a single item in my dictionary, I can use the item property to do that. So I'm going to get rid of the line which removes all of my items from my dictionary and replace it with a line which displays a message box. And the message box is going to display the name of the first item I've added into my dictionary, which is this worksheet object called sheet 1 with a key of sheet 1. So I'm going to reference my dictionary, and I'm going to refer to the item property and open some parentheses. You'll see it requests the key of the item I'm referring to. So the key is this alphanumeric string, sheet 1, and I say dot name, which is a property of a worksheet object. I know that this property exists, although it doesn't appear in the IntelliSense, of course. And if I run the subroutine at that point, it will simply show me the name sheet 1, because that's the name property of that object. Just as with a collection, the reference to the item property is actually optional. Item is in fact the default property of a dictionary class, so what I can do is remove the .item and simply directly reference the key of the object or the item I want to refer to using a set of parentheses and double quotes. So if I run the subroutine again now, it will be exactly the same as though I said my dictionary .item sheet 1, just without having to specify .item. In a collection, it's possible to reference items in the collection based on their index number. So if I quickly switch back to my Using Collections module, I could display a message box which shows me the title of the first item in the collection. So I could say message box, my films, dot, I could say item 1 dot title. But of course the item property of course is optional, so I could remove that as well. And this will show me the title property of the first item stored in the collection, which happened to be the Avengers. Now I can't do that in quite the same way for a dictionary. The item property requires the key of the item. So if I tried to replace this with a reference to an index number, and again the dictionary is based from a value of 0, so that would reference the first item, I can't do this either directly, like so, nor can I do it by explicitly stating the item property either. It still fails. What I can do, however, is replace the item property with a reference to the items method. And what the items method does is it returns a 0-based index of the items in the dictionary. So if I say items 0 dot name, that will reference the name property of the worksheet object. If I run the subroutine now, it will show me that the name of the first item is sheet 1. So to shorten that, because it was slightly waffly and long-winded, if you want to reference an item in a dictionary by name, use the item property and use the key of the object that you've added. If you want to reference the item by its indexed position, then use the items collection and pass in the position of the object. So this time I'm going to pass in the number 1, which will refer to the second item in the collection or in the dictionary, and that will return the name of this workbook object. One quite interesting feature of referencing an item by key in a dictionary is that if that key doesn't currently exist, the dictionary will automatically create it and leave the item or the value element empty. So for instance, if I use my message box to try to display, let's see, my dictionary, open parentheses, film 2, which of course doesn't currently exist, there's film 1, but film 2 isn't there. If I attempt to run through this subroutine, I'll find that when this message box appears, there won't be any information to display on it, so it'll be an empty message box. But when I run this line now to find the count of items, I've apparently added 1, 2, 3 items to the dictionary. But when I execute this line, I'll find that it tells me there are 4 items in the dictionary. One of them is called film 2, it just doesn't have any item stored in the item element. As it's possible to inadvertently add an item to a dictionary simply by referring to a non-existent key, a dictionary class provides you with a way to test if a key exists. So if I, above this message box, say if mydictionary.exists, what I can then do is try to test for the key that I'm looking for. If I pass in film 2, for example, I can then say then, and then if it does exist, I can do something useful. So I could, for instance, print out or display a message which says my dictionary film 2.title, for example. Otherwise, I'll just display another simple message saying that key doesn't exist. And have end if. Okay, so having done that, if I run the subroutine now, I'll see that key doesn't exist, and I'll only end up with 3 items in the dictionary, rather than that additional 4th item that I didn't really want. The dictionary class also provides you with a way to change the key of any item that belongs to the dictionary. So if, for example, I've added a film with a key of film 1, and I wanted to change it to film 2, for some unknown reason, I could do that using the key property of the item in the dictionary. So let me just quickly add a title to the film object that I've created. I'm going to say f.title equals, and I'm going to make it equal to something like Guardians of the Galaxy. And what I can do then is, once I've added the item to the dictionary with a key of film 1, I can then reference that key I say mydictionary.key, open some parentheses, and then say film1, and I can make that equal to film2 instead. So previously we saw when this if statement ran that the film didn't exist, or that key didn't exist. But when I run the procedure now, we'll see that we get a message box telling me the value or the title property of the item held in the dictionary with a key of film2. One slightly unusual thing about the keys that you add into a dictionary is that they're case sensitive, which is completely different to the way a collection works. The keys in a collection are not case sensitive at all. So if, for example, I was going to reference one of the films in my collection by its key, so let's say a short name one's Skyfall, then saying Skyfall with a capital S is exactly the same as saying Skyfall in all caps, Skyfall in all lowercase letters. It's all exactly the same thing. So the keys are, as I say, are not case sensitive at all. If I run this subroutine, I'll see the same message 3 times. I get Skyfall, Skyfall, Skyfall 3 times. In a dictionary, however, the keys, as I've mentioned, are case sensitive. If I go back to my Dictionaries module, so I've created a key now called film2 with a capital F. If I change my reference to the key with a lowercase f in my if statement, I'll find that that key doesn't actually exist because it's technically different to this one. So when I run the subroutine, I will get that key doesn't exist. Now it's possible to change the compare method of keys in a dictionary, and you can do that by setting a property of the dictionary. So after I've created it up here, I can say my dictionary dot compare mode equals, and there are 3 options. The default one that's selected by so far is the one called binary compare, and that's what makes the searches or the comparisons case sensitive. The middle one, database compare, is only in use when you're programming in Microsoft Access, so it uses a property of the database to decide how to compare strings. What we're going to do is use the text compare option, which will make the comparison non-case sensitive. So now I've got a capital F here, a lowercase f here, but when I run the procedure this time, it will show me Guardians of the Galaxy because now the keys are technically the same. Just as with a collection, you can hold a reference to a dictionary in a public variable, and that makes it possible to populate the dictionary in one procedure and then retrieve items from it in another procedure. So just to demonstrate quickly how that works, I'm going to insert another normal new module, and then I'm going to declare at the top of it a public dictionary variable, which I'm going to call films dictionary. And I'm going to set that to be equal to a dictionary or as a dictionary, and then I'm going to create a subroutine which will populate films. In fact, that will do for the name, populate films. In there I'm going to declare a couple of variables, one to hold a reference to a new film object, so dimf as film. Just in case, I can't remember if I showed you this or not in this video yet, the film class module is very simple. It just has 4 simple class fields. So if you wanted to replicate that, you could create a class module by right-clicking and inserting a class module, and then write out those simple 4 lines of code. There's another video earlier in the series which explains an awful lot more about how class modules work. Once you've declared the variable to hold the film, I'm also going to declare a variable that will hold a range object, and then I'm going to make sure that I create a new instance of a dictionary. So I'm going to say set films dictionary equal to a new dictionary, and then I'm going to make sure that I go to sheet 1, so sheet1.select, and then I'm going to loop over the range of cells in column A, or the populated cells in column A. So I'm going to go for each R in range, and the top cell that I want to start looping from is cell A3, and the bottom cell that I want to loop to is from range A1 dot end XL down. I've used this technique in many of my other previous videos, so hopefully you'll recognise this code by now. I'll fill in the next R statement to make sure I don't forget to do that later on, and then for each of these cells that I encounter, what I'm going to do is set f to be equal to a new film, and then I'll set a couple of the basic properties. So I'll say set f.filmid equals r.value, so that's the value of the cell that I'm currently looking at, and I'll say f.filmtitle, or title as I've called it, I'll make that equal to r.offset 0,1.value. And I could populate the other 2 properties as well by offsetting another couple of columns, but that will do for now. So that's going to store a list of ID numbers and titles in each film object. So to actually add those items to the dictionary now. Once I've done that, once I've set some properties, what I can do is say films dictionary, which is the name of the public variable, filmsdictionary.add, and the key for each item will be the film's title, which I know is unique. Although I could also use the film's ID as well, that's also unique. And then the actual item that I'm going to add in will be the film, so F. What I can then do is set my F variable to be equal to nothing so that it's ready for use the next iteration of the loop. And at that point I've got my list of films populated, and if I run the subroutine, that will populate that dictionary. So now I can write another procedure which returns items from that public dictionary. So let's create another sub called reference items, or something similar to that. It's a fairly short name at least. And if I wanted to reference just a single item in the dictionary by its key or by its index position, I can do that quite happily. So I could say message box, and I could display films dictionary, let's say .items, and I'll use the index position, items 0. .title, so that will reference the title of the first film item in the films dictionary variable. So if I run the first subroutine just to make sure that the dictionary is populated, I can then run the second subroutine to make sure that it returns a value, so it returns the Avengers. So that's fairly straightforward, referencing a single item. At this point, it might actually be more useful to loop over all of the items in the dictionary rather than just referencing a single one. And this works slightly differently to the way it does for a collection. So let's just demonstrate this by adding a new subroutine below the last one we've added. So I'm going to say sub loop over dictionary keys, which is the first technique we'll use. So to do this, we're going to use a for each loop, which means we need a control variable which will hold a single item in the dictionary. If we were doing this with a collection, and if we knew that the collection contained only films, we could declare our control variable as, say, dimf as film, but this isn't actually going to work for a dictionary. What we're going to do, I'm going to declare my variable, I'm going to call it single key, which makes it a little bit more descriptive, and the data type is going to be a variant. To loop over the items in the dictionary then, we say for each single key in, and then reference the films dictionary. Now, if this was a collection, that would be all I would have to do. I'd reference the name of the collection. But with a dictionary, what you then have to do is reference the keys array. So the keys method of the dictionary object returns a reference to the array of all of the keys that are stored. So if I say for each single key in film dictionary.keys, I can then say next single key. And then I can use the value returned to my single key variable to pick an item from the dictionary. So let's say, rather than use a message box, I'm going to debug.print this time, so we can list them all out in one single list. I'm going to debug.print films dictionary .item, open parentheses, and then I can pass in the key that's stored in the single key variable. So single key, and then I can reference a property of that item. As I know that they're film items, I can say .title, for example. So just make sure that that array is populated, or that dictionary is populated, by running the first subroutine. And then I can head to the View menu and choose the immediate window. And then I can run through, in fact, let's step through the subroutine the first couple of times. So let's go through the loop a couple of times using the F8 key. So we'll see that the single key variable holds the key value of each item in the array, each iteration through the loop. So as I continue processing it, it just transfers control to the next item in the keys array. So if I just hit the run button to continue all the way through to the end, that will finish off the entire loop. So that's one technique for looping over items in a dictionary. Loop through the keys array using a for each loop. As well as looping over the array returned by the keys method of a dictionary, we can also loop over the array returned by the items method. So to do that, we can use a standard for next loop rather than a for each loop. So let's declare a new subroutine, which I'll call loop over dictionary items. When I can spell that, there we go, dictionary items. And then to loop over this, or to write this type of for next loop, what we need is a simple integer variable. So I'm going to say dim I as integer. And then the way this type of loop works is we say for I equals, and then we put in the lower and the upper numbers of the bounds of the array that we want to loop over. So if we knew, for example, that the array was numbered from 0 to 12, which I do know in this case because there are 13 films in the list, then 0 to 12 would be the way to make that loop work. But because our array could contain a different number of items each time we run it, what we can do instead is use the L-bound and U-bound functions to return the lower and upper bounds of the array we're interested in. So what I can do here is say L-bound, open parentheses, and then refer to my films dictionary dot items method, and this will return the array that we're interested in, so the items array. So we can say L-bound films dictionary dot items to U-bound films dictionary dot items. I'll say next I, and that's the basic loop written. What we now need to do is reference a single individual item in that array. To do that, we can say films dictionary dot items, and then use the integer variable to specify the element of the array that we're interested in. And again, because we know that there are film objects stored in this array, we can specify any of the methods or properties of the film object. So I can say title, oh, and I wanted to debug.print it, of course, as well. So let's say debug.print at the start of that line. So debug.print whichever item we're currently looking at. So if I click into the immediate window and press Ctrl A and then delete, just to clear it out for the time being, again we can begin stepping through this routine, making sure first of all actually that we've populated the dictionary in the first place. Let's run the first subroutine first, and then step through this one using the F8 key, and we'll see that again it starts processing the loop, but this time using the index position of the items in the items array. So let's just run all the way through to the end by pressing the F5 key, and there's the full list of films printed out. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.